At GCC, you came across the relative atomic mass, which is the number of protons and neutrons in an atom, and the atomic number, which is just the number of protons in an atom. To find the number of neutrons, you would just subtract the atomic number from the atomic mass. However, once you get to A level, you don't have integer relative atomic masses. And if you'll try to calculate the number of neutrons, you'll end up with this. That's definitely not possible. So why is this happening? Let's find out. The problem arises from having a non-integer relative atomic mass. So let's find out why this is the case. The OCI A-level chemistry definition is as follows. It is the weighted mean mass of an atom of an element compared to 1/12 of the mass of carbon-12 atom. Whoa, that makes so much sense. In reality though, it's a very confusing definition. There are two key points. The first is about weighted mean mass, while the second touches on relative mass concept that is used in the periodic table. Let's start by breaking down the first point. What average mass are they talking about? Well, if you'll take a lump of magnesium metal, there will be more than one kind of magnesium atoms. There will be atoms that have a mass of 24, 25, and 26. These atoms have different masses because of different number of neutrons, i.e., they're different isotopes of the same element. And so because magnesium and the majority of other elements in the periodic table don't consist of just a single type of an atom, but rather as more than one different type of an atom, we need to take an average of them to find their relative atomic mass, which we will then be able to use in our calculations. To do that, we need to consider the abundance of each stable isotope of the element on Earth. This is just another way to say that we need to look at the proportion of each stable isotope of the element present on our planet, because not all of them exist in the same quantities. For example, if we have 100 atoms of magnesium, only 11 of them would be magnesium-26, because on Earth it has an abundance of 11%. 10 of them would be magnesium-25 because its abundance is 10%, and 79 of them would be magnesium-24 because its abundance is 79%. Now let's assume for a moment that we don't know the relative atomic mass of magnesium. How would we calculate it? To do that, just imagine that you have 100 isotopes like we already did. Multiply each isotope by its abundance, i.e. percentage, and add them all up. Then you divide by 100 to find the average, which will be around 24.3. So now you know that this 0.3 comes from the fact that it's an average relative atomic mass, not the mass of some specific atom. Right, but what about the units of this mass? Is it milligrams, grams, or kilograms? Neither is true, and this is where the concept of relative mass comes in. The mass of fundamental particles is so tiny that using them for calculations would make our problem solving unwieldy. For example, let's calculate the mass of a carbon-12 atom. It will have 6 protons, 6 neutrons, and 12 electrons. And this will give us 2.01 times 10 to the power of minus 23 grams. And so working with these kind of numbers would turn chemistry from pure fun into suffering. So that's why chemists define the new unit to use instead of actual masses of atoms. Just for convenience, chemists compare all atoms to one standard atom, which they decided to be carbon-12. They assigned it the mass of 12 atomic mass units, AMU, and so the single unit, 1 AMU, is 1/12 of a carbon-12 atom. It is the standard to which any element is compared. For example, helium has the same mass as 4 1/12 of a carbon-12 atom, Chlorine has the same mass as 35.5 1/12 of a carbon-12 atom. And this is where this point comes from in the definition. Alright, we've covered a lot of ground today, so well done everyone. However, you are not ready to ace those A-level exam questions on this topic just yet. So bear with me and watch my next video on the exam technique where I will show how to answer them. Thanks for watching and I'll see you later.